Yes. So everyone can see my screen, right?
Yes.
Yes. So here previously we have discussed about our total AutoCAD drafting commands. So today we are going to enter into HVAC tools. Means for preparing ducting, whatever the parts we have to do. So we have some things for connection ducting and all. So joints, whatever the things. So that way we are going to discuss. So here I am starting now. T enter text, click and pull. So in screen someone is making some drawing here, someone is making here. So can you please erase this one? Okay, I'm starting here. So HVAC ducting parts. So here we have textile, different textile we can load here. For HVAC ducting point, first one we have shoe neck. First one we have shoe neck. Second one we have VCD. So in this one again we have manual, VAV, CAV, and third one we have reducer. So that reducer formula will be W1 minus W2 into 4. So the length of reducer should be 400 to 750. Insulation, again insulation we are having thermal insulation and acoustic insulation. So elbow we are having two types of elbow. One is 90°, one more is 45°. and we have Y joint. So how many things we are having here? Ducting parts. So everyone can see the screen clearly, right?
Yes.
So
Yes, sir.
if you are not seeing clear means this blue screen, we can see this color highlight, right? So here to prepare HVAC ducting, we are having first one will be shoe neck and VCD. In VCD we are having three type. One is manual, second B and
But
C
you
will
have
be,
written VDC.
BDC.
sorry. Okay,
You
sorry,
are saying
VCD.
VCD
Oh,
and
right. Sorry, this is VCD. Right. So VCD. Then we are having three type. One is manual, and one is VAV and CAV. So VAV, CAV is a motorized, and we have reducer. So shoe neck means whenever we are having main duct, in the main duct, if we are taking any branch duct, so there we have to send our air within easy direction, easy flow. To maintain easy flow, we are going to give shoe neck from main duct to branch duct, as well as from branch duct to diffuser connection. After that, VCD we are having. VCD means to control the airflow. To control the airflow, we are having VCD. In VCD, we are having three types of VCD. One is manual, one second one
Sir,
is VAV,
full form of VCD, sir.
volume control damper. One by one will go. So whenever I am discussing that, one by one will go. Right? And VAV means variable air volume. CAV means.
Sorry, Elias, could you please repeat VCD again?
So VCD, why we are using to control the airflow.
What is stand for?
Sorry?
What is stand for? The
Volume control damper.
Thank you. Thank you.
Volume control damper. So here again we are having one is manual. So that VCD we are going to control with hand manually. And second one we are having VAV, variable air volume. VAV means variable air volume. And CAV, constant air volume. So this both belongs to motorized. VAV and CAV belongs to motorized dampers. And next we are having reducer. So reducer means we are running our main duct. In main duct, we are taking branch ducts. If you are taking branch ducts means whatever the CFM. So CFM means cubic feet per minute. Cubic feet per minute. Here, how we are going to measure? Let's say that lengths we are going to measure millimeters, centimeters, inches, feet, kilometers, meters, right? The same way we are going to measure air in CFM, cubic feet per minute, and we are having CMH, cubic meter per hour. So that things and all we'll discuss now. So the reducer formula will be W1 minus W2 into 4. Reducer formula
Sir,
will
the reducer formula is a square meter value. This formula.
formula.
This is a square meter. We can get the square meter from this formula.
Yeah, we can. No. This is to find reducer size.
Okay.
So how much reducer we have to give size. So reducer size how we have to get W1 minus W2 into 4. So here
Sir,
W1
do you mean by size? Sir, do you mean by size the length of the reducer?
length of reducer.
Yes, thank you.
So here I am taking briefly, then whatever one by part, one by one we are going to discuss, right? There I'll take you brief. Just I'm giving you here idea. So W1 stands for main duct. After reducing CFM, we are going to do second duct. Means main duct to branch duct in singular duct only. So W1 stands for big duct, W2 stands for small duct. Big duct minus some small duct into 4. So that is length of the reducer. That length should be in between 400 to 750. Length should be in between 400 to 750. If we are getting length below 400, we are going to take 400. If we are getting length above 750, we are going to take 750. But in between 400 to 750, whatever we are getting, the same we are going to maintain. Maybe if we are getting 500, we are going to select 500 reducer. If you are getting 600, we are going to select 600. Clear? And then we are having insulation.
Sir, it's not clear with me because when I calculated 400 minus 750, it's equal minus 350.
No.
Into 4 equal 1400
No.
millimeter.
No. Actually, see, this W1 stands for main duct, big one. So one by one we will go. So then you will get one item. Maybe you are thinking that 400 minus 700, right?
Yes.
That length of the reduction, it should be 400 to 750. 400 to 750, not 400 minus 750.
Okay.
Length of reduction should be 400 to 750.
How about into 4?
That is formula. We'll go. First I'll close this thing, then
Okay.
we'll go one by one. Okay. And now, so here we are having next one, insulation. So the insulation, the purpose of insulation in air conditioning, in the duct we are going to set our conditioned air. It means cool air, conditioned air, cool air. How you will feel comfort, or supply air, right? Let's say that you are having one glass, empty glass. General practical I am giving you. If you are having one glass, in the glass you are going to fill with cold water. In your glass you are going to fill cold water. After some time what will happen? Surrounding of the glass, you will get some water molecules, water drops.
Shabba, చచ్చిపోతున్నాడు వీడు. Insulation.
Right? So for avoid that water molecules and all, we are going to provide insulation. So insulation we are having thermal insulation and acoustic insulation. The thermal insulation we are going to place over the duct, means above the duct, and acoustic insulation we are going to place inside the duct, near the equipment. Wherever we are having our equipment, near the equipment we are going to place acoustic insulation from equipment starting to up to 3 meter. Acoustic insulation, enter ducting we are going to place. So this is about insulation. So thermal and acoustic insulation, we have different sizes in market. So depending upon our requirement, we are going to insulate the ducting. And next we have elbow. So elbow we have two types of elbow. One is 90 degree, one more is 45 degree. The elbow why we are using? To change the route of the duct. To change route of the duct. And Y joint to split the ducts, to split one duct to two ducts. Clear guys about here, everyone? Guys understood here?
Yes, sir.
Okay.
So
It's clear for me.
yeah,
Sir, one question is there.
yeah,
Sir, even if we are using a jet piece also, na?
jet piece, yes.
Yeah. Otherwise it is called otherwise CT crosstalk silencer, CTS.
CTS, silencer.
Yeah, yeah.
So silencer, we have different silencers. So usually the silencer it won't come in HVAC. That is for to reduce your sound. Usually we are going to
But
use
it is included in HBC partner, right?
HVAC only, but most probably we are not going to use that one. So for that one, we are going to use canvas cloth. So that is too expensive, right?
Actually, we have used that CTS in our recent project. That's why I asked.
Okay. So up to in this my experience, I did not use CTA now up to now because we are
Okay.
going to keep our equipment somewhere and we are going to distribute ducts in some other place. If you are using CSU unit will come below 10 tier only. In 10 tier, you won't get that much voice, that much noise. So if you use canvas cloth, that's more than enough.
Sir, some of the guys on WhatsApp group says that they cannot hear your voice on Zoom meeting. So you can answer them via WhatsApp group.
Yes. So if anything is there, please may ask me in Zoom only. So because I can't see again and again my WhatsApp group.
For me, I understand till now.
Yeah, right. Everyone clear with my eyes? Now we are starting now here. So yes, I'm changing unit color. REC enter rectangular. So here I'm going to keep my unit. So single line drawing I'm giving here. See if you see here, this is my equipment. So different types of equipment we are having. AHU, air handling unit, FCU, fan coil unit, and CSU, ceiling suspended unit. So that equipments and all selection, what are the names? While our CFM selection and ducting, we are going to discuss. So here I am giving here T enter text. So EQ means equipment. And LE enter ladder line. So I want to change my ladder lines type. D enter diamond style. Modify. Going this one. 20 enter. Right. From my equipment, air is going towards this way. So here, this is called main duct. This is called as a main duct. So here we are having main duct. For main duct, we have number of branch ducts. So different colors I'm using, guys, because of your understanding. Just I am indicating that my airflow direction.
Engineer, yes. Do we have an HVAC code standard we follow, or just international code standard?
Yeah, we are following ASHA standards.
Well, what's SS standard stand for?
American Society Heating, Refrigeration, Air Conditioning.
Okay.
So different countries.
ASHA?
ASHA means American Society of Heating Refrigerator Engineers. So different countries, they're having different standards. So India having ISHRE, Indian standard, but universal wise people are
Repeat
following
again.
ASHRE.
American standard of what?
Sorry,
Repeat again, please. American standard of what?
American standard of heating.
Okay.
Guys, getting my voice? Hello.
Yes, I'm getting a lot of noise.
Yeah,
American Society of what?
American Society of Heating,
Aywa,
Refrigerating,
and refrigerating.
and Air Conditioning Engineers.
Air conditioning.
American
Engineers.
Society of Heating, Refrigerating, and Air Conditioning Engineers. Okay, guys.
Okay.
Right.
This is Ashri.
This
Am
is
I right?
ASHRE. This is ASHRE.
Okay.
So for India, we are having ISHRE. So Indian standard. So starting how we are having American Society, like that Indian standard. Remaining will be same.
Okay. Thank you.
Yes. So HVAC ducting preparation and HVAC, we are going to use ASHRE standards only. Whatever I am going to share with you course, that belongs to ASHRE only. Now here, if you see here, this is my equipment. From equipment, air is going towards this direction. You can see this arrow symbols, right? This is called main duct, and yellow one called branch ducts. From main duct to we are segregating our ducts. Now, first we are going for shoe neck. The purpose of shoe neck is, see here I am going to make now double lane drawing. This is my main duct. In this main duct, I am having air, right? This air I have to take turn to main duct to branch duct. No, just both compare you guys, then you will get an idea. So let's say that here I am having two branch ducts. So two branch duct, one duct I am maintaining towards this direction 45-degree angle, and one duct I am maintaining 90-degree angle. In this both duct, which duct is will enter easily?
45-degree.
45-degree angle, right? So the because of air and water, for air and water, it doesn't have any shape and size. Air and water, we can find that straight road only. Straight road, it won't take any direction. So here what happened, air is going straight manner. If you want to take a turn, early enter later line. So if you are not maintaining any shoe neck, air will enter 90-degree angle. If you are going to maintain shoe neck it stands for 45-degree angle. It will enter easily to the our duct. So this shoe neck size, how we are going to find? Here I am going to do shoe neck. L enter line. Just select this end to this end and select this line. M enter move. You should move 150 mm. It means 6 inches. Which side is your airflow? For ducting, left side or right side? Which side is air coming?
Left side.
Left side. So left side duct again half set 150 mm. So this is a reference line. After that, L enter line. From this point to this point, how to make line? Then you delete this reference line. E enter erase. TR double enter trim. Just you are going to trim this one. This is your shoe neck. Preparation of shoe neck. From main duct to 150 mm half set you are taking. After here again 150 mm you are going to maintain 40-degree angle. So 45-degree angle, to maintain 45-degree angle we are going to maintain shoe neck. Clear? So if you are maintaining shoe neck, what will happen? Your air will pass easily into the main duct to branch duct. So here also I am having L enter line. Actually for shoe neck sizes we are having 100 mm and 150 mm. So 100 mm, 150 mm shoe neck size. If your duct below 600 width, you have to select 100 mm shoe neck. If your duct having more than 600 mm width, you have to select 150 mm. But here how much we have selected?
150 mm.
150. The purpose of 150 why I have selected without checking dimensions and all. Let's say that your equipment is carrying number of branch ducts. In number of branch duct, maybe some ducts will come below 600 size, some ducts will come above 600 size, right? It means you have to maintain few shoe necks will be 100 mm, few shoe neck will be 150 mm. So if you are giving 100 mm different quantity and 150 will be different quantity, so that is difficult for manufacturer. We are getting ducting from maximum outsourcing. Even if you are having one manufacturer plant also, whenever manufacturer is supplying, is doing new shoe necks and all, it's very difficult to him. Again and again he have to change dimensions, whatever the sizes, things and all. For that reason, what we are giving, we are maintaining standard size will be 150 mm. Because I have seen personally that inside number of shoe necks are getting rejected because of this small issue. Clear?
So, sir, for the shoe neck for below 600 mm width, the shoe neck had to be 150 to 100 millimeter.
If it is below 600, we have to maintain
Yes.
100 mm.
It's below 600. It is 100 mm or 150.
100.
100. Okay. It is above when it's above 600 mm.
150 mm.
So 150. This
Yes.
is standard for all ducts.
All duct.
Yes. Okay. Thank you.
But because of manufacturing thing and wastage of ducting in the site, we are taking only 150 mm.
This reference, we get it in ASHRAE?
Yeah, Ashay,
What
will
you are
get.
saying?
Yes, we'll get.
Okay,
100% we'll
so-
get.
Better, sir, you just mention the code reference as well. Which clause we need to refer to?
Okay, okay.
Yes, because it will be good for us when we make any interview,
Yeah, sure,
Right.
sure.
a job interview. Yes.
Yes, yes.
Okay. So when it's below 600 mm, 100 mm.
100
When
mm, right?
it's above 600 mm, 150.
150, right?
Thank you. Thank you.
Yes. So now here again I'm going to prepare shoe neck. So prepare shoe neck, L enter line, selecting from here to here and move enter, M enter move. How much? 150 mm I'm taking. And which side our air running? From our air is passing from left side to right side. So here O enter half set, again 150 mm. Then L enter line. From this point to this point I'm going to join. Then whatever reference line I'm having, that is I'm going to delete. E enter erase, TR double enter trim. This one I'm going to trim. So this is about shoe neck. So bottom also we are having some ducts. This also we will do. Now
One more thing, sir. Do you will discuss today rectangular ducts or all rectangular and round?
no, this parts whatever we have discussing now. Shoe neck,
Okay,
wheels,
thank you.
dampers. This is applicable for rectangle, square, round, elliptical duct. This we have to use. But when
So
we
the Shonik rule 100 and 150 also applicable for round ducts.
yes, for everything. So here, whenever we are preparing ducting, either it is round duct, square duct, elliptical duct, whatever, doesn't matter. We have to use these things. After that, when we have done our selection of ducting, maybe round duct, square duct, or rectangular duct, then we are going to modify few things. Okay.
Okay. Okay. Thank you.
So our class guys going to end here. I'm ending my link here. So I'm going to send new link.
Okay.